Edx M3 January 2011, question 5 on the topic of horizontal circles. There's the question. Pause the video, have a good look at it. Right, here's the first part of the question with a diagram showing the forces. As usual with horizontal circular motion, we need to resolve vertically and put the forces equal because there's no acceleration vertically, and resolve towards the center, putting the force equal to mv squared over r or mr omega squared. We'll use the latter. So resolving vertically, t1 cos theta, t2 cos theta plus mg. And towards the center, t1 sine theta plus t2 sine theta equals mr omega squared. Now instead of r, let's use this expression for r that I've got down here. So because r over l is sine theta, r is l sine theta. And the reason I'm using that is because now the sine theta cancels out through this equation. That's t2. The sine theta cancels out through this equation and it becomes t1 plus t2 equals ml omega squared. The top equation, when we put cos theta in as 1 over root 2 and tidy it up a bit, becomes t1 minus t2 equals mg root 2. So two simple equations to solve. I'll leave you to check the working, add them up to get t1, and we get t1 equals m over 2 into L omega squared plus root 2g. And going back and using that expression for t1 in the equations on the other page, it's fairly straightforward to show t2 is m over 2 into L omega squared minus root 2g. Okay, so you can just check that you can get those expressions. T1 is the tension in AP, T2 is the tension in BP. Now there's another part of the question here. And to understand what to do for this question, we need to look at the whole wording of the question, right back at the start. And the important thing here in the wording of the question, to allow you to show this bit about omega squared, is that it says this this ball rotates. Yeah, here it is. Both strings are taut. That's the important statement. Both strings are taut. In other words, there's tension in both strings. In other words, well, coming back to the page we're on, in terms of this diagram, T1 and T2 are both greater than 0. Now T2 is the one that could be slack, obviously not T1. So all we've got to do for this last part of the question is say that from the information we're given, T2 is greater than 0. And I can finish that off on this page, I think. I don't need any more room. If T2 is greater than 0, L omega squared minus root 2g is greater than 0, which gives us omega squared is greater than g root 2 over L, which is what the question asked for. I will go off this page now because there was room to put it there. So that answers the last part of the question. Rather than put it on this page, we've just done that. Okay. Oh, mark scheme. So let's just have a look. For realizing theta's 45, there was one mark for that. There was an M1A1 and an M1A1 for both of those resolving equations. And then there was an M1 for simplifying the equations and for solving the simultaneous equations, and 2 accuracy marks one each for getting the expressions for T1 and T2. And then for realizing what to do to show this last bit, that the strings are taut, there was just a single method mark and an accuracy mark at the end there. Okay, thank you for listening. I hope that was useful.